In the majestic, sweeping chronicles of scientific progress, and particularly within the storied pages of astronomical history, there are certain names that eventually acquire a status far beyond simple fame. Over time, they become encrusted with legends, wrapped in an almost tangible mystical aura that elevates them above the mundane. There are names that stand as monolithic symbols, names like Hubble or Voyager. For humanity, these have long been synonyms for unconditional triumph, shimmering icons of our endless process of discovery and the bold, unapologetic expansion of our horizons. You only have to speak these words aloud, and grand technicolor panoramas of distant nebulas, or the iconic images of golden records carrying Earth's messages to unknown stars, instantly flood the memory. However, hidden within this same history, there exists an entirely different category of names. These are the names that professional astronomers spending their long, solitary nights at telescopes and passionate amateur stargazers alike try not to whisper out loud before a critical observation run. These words have become the bitter embodiment of shattered hopes, erroneous prophecies, and loud public fiascos. In recent years, this unspoken blacklist has been confidently topped by a short, resonant word of 5 letters: Atlas. If you follow space news even out of the corner of your eye, the mere mention of this acronym likely triggers a persistent, intrusive sense of déjà vu. The script repeats with frightening, almost cinematic precision and inevitability, as if some invisible director up there is playing the same broken record over and over again, ensuring it always ends in tragedy. Let's try to reconstruct the timeline of this closed loop in excruciating detail. It always starts with a loud sensation blowing up the news feeds. Headlines in online tabloids and respectable newspapers literally scream about the appearance of a new, incredibly bright, mind-bending comet. We are promised the celestial show of the century, a spectacle comparable only to the second coming of the legendary comet Hale-Bopp, or the famous Halley's Comet. Astronomers rub their hands in anticipation, prepping and tuning their ultra-expensive optics. Regular folks mass download star map apps and buy up binoculars in a frenzy. But then, at the most critical, most high-stakes moment, right when the tension of expectation hits its absolute peak, the mysterious object simply vanishes. It crumbles into dust, dissolves into the boundless darkness of space, leaving us all in a state of deep bewilderment and profound disappointment. This hasn't happened just once, or even twice. It has turned into a frightening pattern, a systemic glitch in our expectations. Across the vast expanses of the internet, on specialized astronomy forums and social networks, a theory is being discussed in all seriousness: the so-called Curse of Atlas. Users argue heatedly, is this name some kind of black mark for celestial bodies? Why do comets discovered by this specific survey system act like kamikazes? Who, or what unknown force, ruthlessly destroys them on their approach to Earth, as if shooting them down with an invisible planetary defense missile? To truly grasp the sheer scale of this cosmic drama, we need to rewind the tape of time and mentally return to the spring of 2020. Remember the oppressive, heavy atmosphere of those days. The world is rapidly plunging into the chaos of a global pandemic. Cities are locking down, people are trapped in their apartments. The future seems foggy, frightening, and anxious. And suddenly, like a bright ray of light piercing this dark kingdom of uncertainty, joyous news arrives from the depths of space. A great comet is flying toward Earth. It was given the official name C2019Y4, Atlas. The scientists' forecasts were not just optimistic, they were truly fantastic. Astronomers confidently predicted that by May 2020, this celestial wanderer would flare up so brightly it could rival Venus itself. It was hastily christened the Comet of Hope, the Comet of a Generation. People exhausted by the constant fear of the virus saw it as a good omen from above, a sign that beauty still exists in the universe, that the cosmos is sending us a greeting and support in our darkest hour. Hundreds of thousands of people around the world bought optics, preparing to meet this beautiful guest. But in April 2020, as the comet approached the orbit of Mars, something inexplicable happened. Its brightness chart, which by all calculations should have been soaring upward like a rocket, suddenly crashed. Photographs taken by the Hubble Space Telescope shocked the global public. Instead of the dense, glowing core we expected to see, the images revealed a swarm of small, dim fragments, resembling, as astronomers sadly joked at the time, hamburgers in space. The comet's core couldn't take it. It died before it ever reached us. It crumbled like a fragile sandcastle in a strong wind. The disappointment was truly global, but back then, in 2020, we wrote it off as a tragic accident. Well, it happens, we said. Comets are delicate, fragile creatures. Fast forward 4 years. The calendar reads fall 2024, and once again, a discovery by the very same system, the robotic telescope ATLAS. A new object, Comet C2024S1. And again, we see the exact same headlines as if copied word for word from the archives of 2020. The second sun, the Halloween ghost, the spectacle of the millennium. And again, the same painfully familiar and sad finale ensues. The comet began to fall apart on the distant approaches, and upon its close encounter with the sun, it was completely annihilated, turning into a cloud of superheated steam. 2 loud promises of a miracle, 2 loud crushing failures, and one common name linking these events, Atlas. This is exactly where conspiracy theories enter the game. The human brain is wired in such a way that it categorically refuses to tolerate coincidences. If something happens twice following the exact same script, we instinctively look for a pattern. We look for hidden intent. UFO forums and esoteric message boards are overflowing today with versions that would give any academic scientist a nervous tick. But these versions remain extremely popular with the public because they offer a simple, understandable explanation for complex, chaotic processes. One of the most widespread conspiracy theories claims that the solar system is under protection. Allegedly, there exists some kind of energy dome, an impenetrable barrier, or an automated planetary defense system left to us as an inheritance by ancient advanced civilizations, or curated by extraterrestrial intelligence. According to this bizarre logic, the comets we observe aren't just dirty snowballs flying through the void. They are disguised spy probes, containers with biological weapons, or scout ships of hostile forces. And some invisible cosmic patrol ruthlessly shoots them down at the distant perimeter, preventing them from getting too close to Earth. That is exactly why, the conspiracy theorists argue, they explode and disintegrate without any visible cause. In this modern mythology, the name Atlas becomes something like a targeting marker, an IFF tag, identification friend or foe. Anything tagged with this name is subject to immediate liquidation. They don't want us to see this. Anxious commenters type in the dark corners of the web. We are being protected from something terrible. This theory, for all its obvious absurdity, is very psychologically convenient. It turns a cold, indifferent, and empty universe into a place where someone is looking out for us, even if in such a strange, aggressive way. Of course, to a rational person, this all sounds like the synopsis for a cheap paperback sci-fi novel. But, as veteran detectives love to say, inside every lie, there is a kernel of truth. Behind this mystical curse and the wild conspiracy theories hides a real physical and technological riddle that gives astrophysicists no peace. Here's the thing. Atlas isn't a person's name, nor is it the surname of a famous scientist discoverer. It is an acronym. ATLAS, Asteroid Terrestrial Impact Last Alert System. It is a global network of robotic telescopes located in the Hawaiian Islands and the Southern Hemisphere. These tireless robots work every single night, automatically scanning the entire sky, sector by sector, without breaks for sleep or rest. Their main job isn't finding pretty comets to delight photographers. Their job is much more prosaic and terrifying. They are looking for death. They are watching for dark, fast rocks heading toward Earth to destroy a city or an entire continent. The settings of this system, its eyes and brains, complex image processing algorithms, are specifically tuned to find a certain type of object. They see what other classic observatories miss: faint, diffuse, fast-moving spots against the backdrop of stars. And so, it happens that this very robot hunter, tuned to find threats, fishes out of the cosmic darkness the most unstable, the most fragile, the most defective material in the solar system. We are dealing with classic survivorship bias, but turned inside out. Old telescopes discovered big, bright comets because those were the only ones they could see with their equipment. Big comets are generally solid and monolithic. They survive the journey. The Atlas system, however, sees the small fry. It sees loose clumps of dust that are barely holding together. It discovers them by the dozen. And, quite naturally, the majority of these weaklings fall apart at the sun's first sneeze, at the slightest heating. But since we, the general public, only hear the loud announcements of discoveries, we get the false impression that it is specifically the Atlas comets that are exploding and dying. We don't see the full statistics. We only see the tragedy of our hopes. But even if we cast aside statistics and probability theory, the question of fundamental physics remains. Why do they explode? What happens inside a mountain of ice the size of Everest in the second before catastrophe? It looks nothing like the peaceful melting of an ice cube in a glass of whiskey. It looks more like a detonation. When a comet's core cracks, fragments fly apart at high speed. This is a powerful release of internal energy. It is a tectonic shift in microgravity. It is a process that turns classical Keplerian celestial mechanics, where all bodies fly along smooth, predictable ellipses, into the chaotic ballistics of a frag grenade. Today, we will attempt to strip this name of its mystical coating and dissect the anatomy of these catastrophes from the standpoint of hard, uncompromising science. We are opening the case file on the two most famous John Does of recent years, the comet of 2020 and the comet of 2024. We will conduct a thorough comparative analysis. We will look at their orbits, study their chemical composition, analyze how they behaved in the weeks leading up to their demise. We will see what these sisters in misfortune, separated by 4 years of cosmic void, have in common. Is space truly hostile to these wanderers? Or do they carry a hidden self-destruct mechanism within themselves, a kind of time bomb wound up billions of years ago, back at the moment of the solar system's birth? Could it be that this notorious curse isn't magic, but a design defect in matter itself? Get ready. We are starting our investigation into the serial killings of comets. Our prime suspect, the immutable laws of physics. Our key witness, the dispassionate and soulless robot telescope Atlas. The victims, giant blocks of ice that dreamed of becoming bright stars, but became only gray dust on a lens. And the first fact we must accept and internalize: there are no curses in the universe, only the yield strength of materials and our purely human tendency to see drama where there is only cold thermodynamics. But sometimes, watching yet another comet of the century turn into nothing, it is very hard not to believe in an evil fate pursuing this name. To understand why history repeats with such frightening inevitability, we need to open the dusty archive files and return to the case from 4 years ago. We mentally transport ourselves to the beginning of 2020. That is when the first loud, resonant case of what would later be called Atlas syndrome was recorded. The object receiving the scientific designation C2019Y4 became the ideal patient for our postmortem examination. Unlike our recent guest, which heroically perished in the flames of the sun, the 2020 comet disintegrated in deep, icy space, far from the star, and this circumstance makes its death even more mysterious for the layman, but perfectly understandable and logical for a physicist. Let's look closely at the evidence. Comet Y4 Atlas was, in essence, a giant. Its gaseous atmosphere, or coma, at one point puffed up to colossal dimensions, exceeding the diameter of the sun itself. It was a titanic sphere of cyanogen and carbon, glowing in telescopes with a ghostly, toxic green light. The orbit of this body was incredibly elongated, like a sharp needle piercing the solar system through and through. Calculations showed that the last time this wanderer was in our neighborhood was about 5,000 years ago. This means it saw the rise of ancient Earth civilizations, the building of the pyramids. And here it was, back to put on a grand show for us. But instead of a triumphant passage across the firmament, we saw an inglorious breakup. What killed the comet in the cold void, where there is neither extreme heat nor strong tidal forces capable of tearing it apart? The answer lies in the internal mechanics of the cometary core. We are used to thinking of comets as solid rocks flying through space, but this is a fundamental error. Modern science uses the model proposed by astronomer Fred Whipple, the dirty snowball model, but even this definition is often too flattering for most comets. The density of their cores is often lower than the density of water, and sometimes even lower than the density of styrofoam. This isn't a granite monolith. It is a loose conglomerate, a pile of cosmic rubble, dust, and ice, held together only by a wing and a prayer and negligibly weak self-gravity. Imagine a shaky structure made of sand and loose snow flying in an absolute vacuum. As long as it is far from heat, it is relatively stable. But as soon as sunlight begins to even slightly warm its surface, a monster awakens. The ice begins to sublimate, turning directly into gas, skipping the liquid phase. But this process happens unevenly. The comet's surface is extremely heterogeneous. In some places, the dust layer is thicker and protects the ice. In others, it is thinner. In some places, deep cracks and canyons open up, leading into the very bowels. Gas bursts out not in a calm, even flow, but in powerful, narrow jets. This is the exact moment the physics of catastrophe begins. Every such jet works like a powerful rocket engine. Remember Newton's third law: action is always equal to reaction. The gas bursting out at high speed pushes the core in the opposite direction. Since these natural engines are located chaotically on the surface and fire unpredictably, as the comet rotates under the sun's rays, they begin to spin the core faster and faster. This phenomenon is called the Yorp effect, Yarkovsky-O'Keefe-Radzievsky-Paddock effect, or simply put, reactive torque. The comet begins to spin faster, faster, and faster. For a loose, fragile body, rapid rotation is certain death. A monstrous centrifugal force arises. It tries to pull the particles of matter apart in different directions. Weak gravity tries with its last strength to hold them together. It is a cosmic tug-of-war. In the case of Comet Atlas 2020, centrifugal force won the victory. The core simply could not withstand the speed of its own frantic rotation. It snapped, first into 2 large fragments, then into 4, and then it turned into a disorderly swarm of debris, each of which continued to vent gas, only accelerating the chaos. The Hubble Space Telescope captured this dramatic moment. Instead of a single bright point, we saw dozens of small, fading shards flying in formation into the abyss. The comet committed an act of involuntary suicide, spinning itself up to its breaking point. Now, let's transport ourselves to our time, to the year 2024, to our recent case with Comet C 2024 S1, Atlas. The scenario at first glance seems different. It died flying point-blank into the sun, but the deep mechanism that triggered the destruction process was exactly the same. Fragmentation began long before passing perihelion. Why? Because this family of comets, as we have already found out, are fragments of an ancient giant that broke apart thousands of years ago. They are inherently defective. They have, as engineers say, accumulated material fatigue, microcracks, hidden cavities, stress zones. All of this is the legacy of the turbulent history of their origin. Here we come right up to the main question that feeds all the conspiracy theories. Why does the Atlas system find specifically these defective comets? Is the universe purposefully slipping this telescope only things that are destined to blow up? The answer lies in observation technology, not mysticism. The Atlas system was created and funded not for beauty and science, but for security. Its main mission is saving humanity from a strike from space. It looks for dangerous asteroids that could crash into Earth. Therefore, all its algorithms are tuned to search for anything that moves fast and has an unusual trajectory. Old telescopes of the last century searched for comets manually or using photographic plates with long exposure times. They noticed objects when they had already become big, bright, and stable. The Atlas system is a giant robot vacuum cleaner that collects all the celestial trash. It sees objects that previously went unnoticed precisely because of their weakness, dimness, and diffuseness. It finds small, loose, dying bodies that are on the very brink of disintegration. This is the so-called observer effect. We have started seeing more comet deaths not because comets have started dying more often, but because we bought a powerful microscope that allows us to see these deaths in detail. We are observing a paradox that can be called the survival paradox. Big, dense, boring comets survive. We see them, but they rarely create sensations quietly flying by. Small, active, unstable comets are the ones that put on fireworks. They are bright because they are actively evaporating, losing mass. They attract attention. The Atlas system specializes in detecting exactly these borderline objects. It fishes out of the dark those who are already doomed to perish. One could say that the name Atlas is not a curse, but a medical diagnosis. If a comet is discovered by this system, the probability that it is a small, hyperactive, and fragile piece of ice is much higher than if it were discovered somewhere in the Kuiper Belt by big stationary observatories. Let's deepen our understanding of the chemistry of this process to finally dispel the myth of the cosmic force field that allegedly keeps comets away from Earth. Spectral analysis of Comet Y4 showed an anomalously high content of cyanogen and diatomic carbon. These are the very substances that give comets their characteristic beautiful green color. But their presence also says that the core was extremely rich in volatile substances. It's like dry ice. It evaporates violently and quickly. The more volatiles, the more gas is released, the stronger the reactive thrust of the jets, the faster the rotation. The comet was literally pumped with energy to the brim. It was too active for its own good. Comparing the two Atlas comets, 2020 and 2024, gives us the perfect picture of two types of cosmic death. The first, death from internal instability and rotation, cold death far from the star. The second, death from external thermal impact and sublimation, hot death near the sun. But the outcome is one, a loud promise of a great spectacle that turns into a dud. And in both cases, the key role was played by the internal structure of the core. We are dealing not with solid bodies like rocks, but with loose aggregates that behave like a liquid or granular material in microgravity conditions. In material science, there is a term, ultimate tensile strength. For steel, it is enormous. For stone, significant. For a comet core, it is negligible. Some researchers compare the strength of cometary matter to the strength of an airy meringue or a burnt bread crust. You can literally crush comet matter with your fingers. Now imagine that this giant meringue, a kilometer in size, is spun in a centrifuge or heated to 1,000 degrees. The result is predictable: explosion, disintegration, dust. Thus, the notorious Curse of Atlas is actually the story of how humanity learned to find the most vulnerable objects in the solar system. We are looking at celestial kamikazes. Every time the name Atlas appears in news headlines, you should read it not as a promise of a miracle, but as a serious warning. Attention! Object detected with high probability of structural failure. This isn't a 100% guarantee of failure, but it is a very alarming symptom. We live in a unique era when astronomy has moved from passive contemplation of eternity to active monitoring of chaos. We see Live on Air, how the solar system grinds up and recycles its construction debris. And these two comets, separated by 4 years, became the most graphic victims of this endless process of cosmic recycling. They weren't shot down by angry aliens. They simply didn't pass the harsh stress test arranged by the impartial laws of Newton and thermodynamics. But one important question remains, which we will carry over to the next part of our investigation. Why, despite all this scientific knowledge and facts, do we believe in a miracle every time? Why do even professionals looking at the charts deep down hope that this one will definitely survive? Our investigation moves into the decisive phase. We have gathered the full dossier, examined all the evidence, and understood the motives of the physical forces acting in the airless vacuum. Now comes the time for the trial. In the dock, humanity's shattered hopes for a great spectacle. Acting as the prosecutor, harsh reality recorded by the dispassionate censors of telescopes. We must reconstruct step by step the timeline of the catastrophe for our two main heroines, the comet of 2020 and the comet of 2024, and understand at exactly what moment the dream turned into cosmic dust. This is the climax of the drama, where the lead roles are played by gravity, centrifugal force, and relentless entropy. Let's go back to April 2020. The whole world, locked down in quarantine, craves a miracle and beauty. Comet Y4 Atlas is rapidly approaching the sun. Its brightness is growing strictly according to the chart astronomers romantically call the curve of hope. But in the first days of the month, something strange happens. The curve breaks. The brightness doesn't just stop growing, it starts plummeting. This is the first alarm bell. It's like a sudden cardiac arrest on an ICU monitor. Amateur astronomers who just yesterday were taking beautiful pictures of a green misty sphere now watch in horror as the comet's core elongates, deforms, and loses its sharpness. Something has gone wrong. The heavy artillery of science enters the fray, the Hubble Space Telescope. On April 20th, it targets the comet's coordinates to deliver the final verdict. The image it transmits to Earth becomes one of the most detailed and impressive snapshots of a celestial body's death in the history of astronomy. We expected to see a dense shining sphere ready to flare up with a tail. Instead, the images showed a chaotic swarm. It looked like a fragmentation grenade at the moment of detonation, frozen in time. The comet's core had broken into 4 large fragments and dozens of smaller pieces of debris. They flew in formation, shrouded in a common cloud of glowing gas, like a squadron of ghost fighters departing into oblivion. This was the moment of truth. The comet of the century had officially died, but precisely at this tragic moment, it became a true scientific sensation. Hubble allowed us to see with our own eyes exactly how comets die. We saw the fragments slowly drifting apart, nudged by reactive jets of evaporating gas. We saw some of these shards flare up brightly and fade, like light bulbs burning out before going dark forever. It was an agony stretched across millions of kilometers of space. For the public, it was a bitter disappointment. The promised show is canceled, the second sun is called off, you can return your tickets. But for science, it was a genuine triumph. We got the rarest opportunity to peek inside a comet without landing on it or drilling a borehole. We saw its insides put on display. It turned out that inside, it was just as loose, heterogeneous, and chaotic as it was on the outside. It wasn't a rock, but a pile of cosmic garbage that had pretended to be a planet for billions of years. Now, let's transport to October 2024. The script repeats, but with new sets and special effects. Comet S1 Atlas. This time, the killer isn't internal rotation, but the external solar furnace. The climax of this story was supposed to happen on October 28th, the day of perihelion passage, the closest point to the sun. The whole world held its breath, waiting for the comet to enter the field of view of the coronagraphs of the SOHO Space Observatory. These instruments are our eyes, capable of looking straight at the sun by blocking out its disk. The anticipation was electric. Astronomy forums were buzzing. Will it survive or not? This question was asked more often than the weather forecast. And then, at the appointed time, the comet appears at the edge of the monitors. But this is absolutely not the triumphant entrance everyone was waiting for. Instead of a bright, sharp, shining point with a powerful tail, we see a pale, blurry, barely noticeable smear moving toward the sun like a doomed moth to a candle flame. Hour by hour, it becomes more transparent and ghostly. This is a ghost comet. The core is already gone. It disintegrated on the approach, unable to withstand the monstrous thermal shock. What we see on the screens is merely a cloud of dust that, by inertia, retains the shape of the former comet but no longer possesses its solid essence. The moment of final climax arrives when this cloud approaches the sun at minimum distance. Total absolute annihilation occurs. The dust instantly evaporates. The gas ionizes into plasma. The remnants of matter merge into the raging solar wind and vanish without a trace. Comet Atlas didn't just die. It was erased from existence, crossed out of reality. Not even fragments remained, as in the case of the 2020 comet. Only individual atoms scattered in the solar corona. It was a clean, sterile finale. The Halloween head lost its head in the most literal sense of the word. Here we come to the main plot twist of our story, to the very turn that justifies our long investigation. We accuse the Atlas system of finding defective comets. We accuse the universe of a non-existent curse. But in the court of facts, it turns out we are judging a fish for its inability to fly. The drama of these comets is not a drama of failure or mistake. It is the drama of natural selection. We have witnessed the work of a giant cosmic separator. The solar system isn't a static museum, but a living mechanism that constantly cleans itself. Planetary gravity and the heat of the sun work like a giant sieve. Large, durable objects survive and become great long-period comets, like Halley's Comet, returning to us for centuries. Small, loose, weak objects are ruthlessly filtered out. They are destroyed, replenishing the reserves of interplanetary dust. The Atlas system, thanks to its incredible sensitivity, simply allowed us to see this filtration process in real time. We saw not a curse, but a necessary sanitary treatment of the solar system. Why is this so important to us? Because every such death is an answer to the fundamental question of the origin of life. When the 2020 comet disintegrated, spectrometers recorded the release of a massive amount of organics: cyanogen, carbon, ammonia. These are the basic building blocks of life. When the 2024 comet evaporated, it saturated the solar wind with oxygen and hydrogen. We see comets working as cosmic couriers. They carry water and organics through space. But to deliver the cargo to the address, the courier sometimes must die, must break apart. The destruction of a comet is the only way to release its contents. If they didn't break apart, they would just fly forever as sealed time capsules. A comet's death is the moment the package is unpacked. The verdict of our improvised court sounds paradoxical. The Atlas comets are guilty of deceiving the expectations of the general public, hungry for bread and circuses. But they are fully acquitted by the laws of physics and the evolution of star systems. They honestly performed their natural function. They showed us what the periphery of our solar system is actually made of. They showed us how fragile ice is in the face of cosmic fire, and they reminded us of an important truth. In space, there are no guarantees. Any forecast is merely a probability, not a promise. For the simple observer on Earth, this verdict has a bitter aftertaste. We were left without beautiful photos against the backdrop of the night city. Telescopes bought in a fit of enthusiasm are now gathering dust in the corner. But for those who know how to look deeper, these events became a source of philosophical inspiration. We saw a majestic mountain of ice, traveling in darkness and silence for thousands of years, disappear in a few hours. This is a great lesson in humility. It is a reminder of the unimaginable scale of forces that govern our world. We are merely grains of sand watching the death of other grains of sand in the flame of a candle. However, the trial is not over yet. The defense has one final weighty argument. Yes, these specific comets died. Yes, the name Atlas has become synonymous with catastrophe. But statistics is a stubborn thing. The law of large numbers tells us that sooner or later, this tireless robot janitor will find a real diamond. Among thousands of loose snowballs, one indestructible monolith will inevitably appear. One survivor, and then all the priceless experience gained from studying these losers will help us understand the victor. Every comet death calibrates our mathematical models, refines our knowledge of the Roche limit and ice sublimation. We learn from nature's mistakes, so we solemnly close the thick case file on the so-called Curse of Atlas. The dust from the breakup of two comets separated by 4 years has long since dispersed into interplanetary space, becoming part of the vacuum. Emotions have settled, screaming internet headlines have been replaced by new sensations, and now we can sum up this cosmic thriller with a cool head and a clear mind. We must answer the main questions left hanging in the air after our hopes for a great show faded. Was it a failure of science? Does the name Atlas really bring bad luck? And what do these events mean for the safety of our fragile planet in the future? The first and perhaps most important conclusion we must draw concerns the reputation of the detection system itself. We started with laypeople calling Atlas the harbinger of comet death. But from a scientific point of view, this system deserves the honorary title of custodian of the solar system. The fact that this robot telescope finds objects that fall apart is not a bug, not a program error. It is a feature. It is its main advantage. It is irrefutable proof of its incredible sensitivity. Previously, we simply didn't see these processes. We saw comets only when they were already big, mature, and bright, or we didn't see them at all. Atlas allowed us to peek simultaneously into the nursery and the hospice of the solar system. We saw just how much garbage is flying toward us from the distant Oort cloud, and just how unstable and weak this garbage actually is. This knowledge is of critical importance for understanding our own past. There is a scientific hypothesis of panspermia according to which water and complex organic compounds were brought to the early scorching Earth specifically by comets. If all comets were solid, rocky monoliths, they would crash into planetary surfaces, causing catastrophic explosions similar to nuclear ones, destroying all living things. But if a significant portion of comets are these same loose meringues as those discovered by Atlas, then their fall looks completely different. They break up in the upper atmosphere, crumbling into fine dust and settling gently onto the surface like fertilizer, saturating it with water and amino acids without causing global harm. Thus, these cosmic losers falling apart before our eyes may be direct relatives of those very couriers of life that made Earth habitable 4 billion years ago. Their weakness is actually our strength and the reason for our existence. The second aspect we are obliged to consider is planetary defense. Do not forget that the main job of the Atlas system is not to entertain us with pretty pictures of comets, but to search for killer asteroids. And the story of comet disintegration gives us an important, albeit slightly frightening, lesson. We are used to thinking about the asteroid threat in terms of Hollywood blockbusters. A huge rock is flying. We send brave drillers with a nuclear charge, they blow it up, and the problem is solved to heroic music. But real observations of Atlas comets show that many small bodies in the solar system are not rocks at all. They are rubble piles, flying gravel pits, held together by weak gravity. If such an object flies toward Earth and we try to hit it with a kinetic impactor or a nuclear missile, we won't deflect it. We will only make it worse. We will simply turn one bullet into a charge of buckshot, one shotgun into 100 pistols. The object will crumble into a giant swarm of fragments, as the 2020 comet did, and this swarm will cover the planet on an even wider front, bombarding vast territories. The cases of comets Y4 and S1 are forcing the military and engineers to completely rethink Earth's defense strategies. We are beginning to understand that each celestial body requires a strictly individual approach. What would work with a monolithic iron asteroid will become a guaranteed catastrophe when dealing with a loose comet core. The so-called Curse of Atlas is actually saving us from dangerous overconfidence, graphically demonstrating the incredible complexity of our potential enemy's structure. Now let's talk honestly about the future. Is the curse lifted? Should we believe the next loud announcement featuring this name? The answer sounds paradoxical. Yes and no. Statistics is an implacable science. The Atlas system will continue to scan the sky with the same high sensitivity, which means it will continue to find dozens, hundreds of small, weak, dying comets. Most news with the Atlas tag will continue to end in a fizzle and disappointment. You just need to get used to this. This is the new normal of modern astronomy. We have moved from artisanal goods, from rare discoveries, to mass assembly line production. And in mass production, the percentage of defects is always much more visible. However, the law of large numbers works the other way too. The Oort cloud, that giant cosmic refrigerator on the outskirts of our system, contains trillions of icy bodies. Among them are not only loose snowballs, but true icy giants, like the Great Comet Hale-Bopp or the Great Comet of the 19th century. Sooner or later, the gravitational roulette wheel will spin us a real jackpot. And with a high degree of probability, it is the Atlas system that will see it first, simply because it watches the sky more intently than anyone else. When that happens, we will see the curse instantly turn into a blessing. We will get months, maybe years of early warning to prepare for the visit of a true Queen of the Night. But until then, we all have to go through a difficult stage of acceptance. We must learn to value the negative result. In big science, there are no bad experiments, only poorly interpreted data. Every comet that crumbled into dust before our eyes gave us its unique spectrum. It told us what it was made of. It showed us how cyanogen and carbon behave in cosmic vacuum conditions. We are compiling a detailed map of the chemical composition of the solar system using these comets as disposable probes. Yes, we didn't get pretty wallpapers for our desktops, but we got gigabytes of priceless data for scientific dissertations that might help us finally understand exactly how life originated on our planet. The final reflection of our long investigation takes us into the realm of human psychology. Why did this story with the curse hook us so deeply? Why are we so eager to anthropomorphize chunks of ice and soulless computer algorithms? Because humans are always uncomfortable in a chaotic, unpredictable universe. It is much easier for us to invent a mythical cosmic shield that shoots down comets, or an evil fate that pursues a specific telescope, than to honestly admit that space is a place where chance and entropy reign supreme. Comets die not because someone wants them to or doesn't. They die simply because gravity turns out to be stronger than cohesion, the force holding molecules together. It is a cold, indifferent world, but in this cosmic indifference, there is its own majestic, severe beauty. We humans are the only beings in the universe who can look at this chaos and see patterns in it. We created the robot Atlas, which every night, while we sleep peacefully in our beds, stares into the black abyss to warn us of possible danger. And even if it sometimes errs in brightness forecasts, it never errs in coordinates. It is our faithful sentry. And the fact that it sometimes raises a false alarm, mistaking a dying swan for a fearsome dragon, that is a very small price to pay for our collective safety. So next time you see a screaming headline in your feed, Comet Atlas approaching Earth, don't rush to skeptically shout, "It's a hoax again." And don't rush to run to the store for an expensive telescope. Just watch. Watch the charts, read the dry reports of astronomers, follow this breathtaking drama of physics. Maybe it will fall apart again. Maybe it will flare up for a moment and go out. Or maybe this next one will become the legendary one you will tell your grandchildren about with rapture. Space is a great lottery, and our ticket has already been bought. We just have to have patience and wait for the drawing. On this note, we finally close our case, but the electronic eyes of the Atlas system remain wide open. Right now, at this very second, somewhere on distant Hawaii, the telescope dome is turning with a quiet whir following the movement of stars, and a sensitive digital sensor is greedily catching photons that have been flying to us for millions of years. The hunt continues, and who knows what will get caught in these nets tonight? More cosmic trash or real treasure? Watch the skies. End transmission.